So let's go ahead and look at your warm up here. So what I ask you to do is just to measure these two angles. So how big is this angle right here? It is what? 80 degrees. 80 degrees. Okay. And then how big is this angle right here? It is 90 degrees. Okay. All right. Now, back over to here. This angle is 80 degrees. So if this central angle is 80 degrees, how many degrees is this arc from here to here? It's 80. Remember, they're just the same, right? 80 degrees. So remember, degrees is just a way to divide up a circle. It's dividing up a circle into 360 equal pieces. So this here would be 80 out of 360 possible pieces of the circle. Okay? So if the central angle is 80, this arc is 80 degrees. Now, everything we've been talking about so far in this unit has been central angles. Today we're going to start talking about inscribed angles, all right? So what I want you to do, down here on the bottom of your circle, it doesn't matter where exactly, just put a point somewhere down here on the bottom of the circle. Anywhere down here, it doesn't matter exactly where. Anywhere down here, just put a point somewhere down there. So what we're about to do is we're about to create an inscribed angle. Okay, an inscribed angle is where the vertex of the angle is on the outside edge of the circle. Okay? So from this point that you drew down here, what we're going to do is draw an angle that goes from here to that point, and then from here to this point right here. Okay? So go ahead and draw that new angle in here. Okay, so you should have something like that. So what I want you to do now is to measure this angle. Measure this angle with your protractor. See how big that one is. Measure that new angle you just drew with your protractor.
Measure it, you said?
Measure it, yes. Measure it with your protractor. Okay, so how big is that new angle there? It's how big? Look, you can see right there, boom. It is 40 degrees, right? Now, we didn't all put this point in the same place, okay? There's no way. We all probably put it in different places, but we all got the same thing, right? Did everybody get 40 on this? Yes. Okay, you should have. If you didn't get 40, it's probably because you didn't connect these up very well up here, or you didn't connect them real well down here. But if you connected these up like they're supposed to up here and you connected these, then this right here is going to be 40 degrees, okay? Now, I want you to see that there is a pattern here. So what do you notice about this angle compared to this angle or compared to the arc? It's half of it, okay? And that is not by coincidence. It's always that way. The inscribed angle is always half of the arc that it makes, okay? So the arc from here to here is 80 degrees. The inscribed angle is 40. So on this one, let's do the same thing. Pick out a point. Just put a point anywhere along over here. It doesn't matter where exactly. Just going to put a point somewhere out on the edge of the circle here. And then do the same thing. Connect from here to here. And then from here to right here. Okay, measure that angle. Okay, how big is that angle?
45.
It is 45 degrees. Okay? 45 degrees. Because again, this angle is 90 degrees, this arc's 90 degrees. The inscribed angle is going to be half of that arc. Okay? And we can go through 1,000 examples like this, and it's always going to be that way. The inscribed angle is always half. All right. On this next circle, what I want you to do is we're going to put 2 points up at the top somewhere here, and then we're going to put 2 points down here at the bottom somewhere. It doesn't matter where exactly. I'm just going to put 2 points up here, and I'm going to put 2 points down here. So we'll put 2 points up here, 2 points down here. And what we're going to do is we're going to draw 2 different angles, okay? So this is going to be the vertex of one angle, and it's going to go to those 2 points. And this is going to be the vertex of another angle going to those 2 same points, all right? So go ahead and let's draw this angle. Okay, so I've got the first angle here. So we've got this angle right here. And now I'm going to draw a second one, where this one's the vertex, to those same 2 points. Okay, now this one, yours is going to be different than mine because we put our points in different places. So they're not going to be the same, but what I want you to do is to measure both of these angles. With your protractor, go ahead and measure both of these angles on yours. Like I said, yours are going to be different, so don't worry if you're not the same. Not the same number as mine. They're going to be different. Okay, so as we think about what's going on here, okay, this angle right here is opening to this arc. And this angle is opening to the same arc. So what's going to be true of these 2 angles right here? They're going to be congruent, right? I mean, it's just common sense. If this arc, or if this angle opens to the same arc as what this angle opens to, they have to be equal. These 2 will be equal, okay? And it doesn't matter where I put these 2 points. If I move this point to right here and it opens to that same arc, it's still going to be 38 degrees, okay? So anywhere, if I drew a third angle from here and from there to there, it's going to be 38 degrees. Okay? Now, on mine, yours is going to be different, but on mine, if my angle is 38 degrees right here, how many degrees would my arc be? My arc would be 76. Write the number for what yours would be. Remember, it's just double that. So take the number on yours, double it, double this angle to get your arc out here. Write that on yours. Okay. Next thing. So on this one, we've got this diameter drawn here, okay? And we're going to think of it as an angle. So if this were an angle and this is the vertex, how many degrees would this angle be right here? Would be 180 degrees, right? That angle would be 180. How many degrees would this arc be from here around to here? 180. It's a semicircle, right? Okay, so what I want you to do, anywhere down along the bottom of this circle, anywhere down here, doesn't matter where, put a point somewhere down here at the bottom. Anywhere along the bottom down here, just put a point, okay? And what I'm going to do is create another inscribed angle. What I'm going to do is this is going to be the vertex, so I'm going to draw from here to this point, and then I'm going to draw from here to this point right here. Very good. When you get that, measure this inscribed angle right here with your protractor. See how big that is. How big is it? 90. Should be exactly 90, right? Why is this going to be 90 degrees? Good. It's just like what we did right up here, right? The inscribed angle is half the arc. If this arc from here to here is 180, this inscribed angle that opens up to that arc is going to be half of that. So half of 180 is going to be 90. Okay? All right. So on this next circle, same thing. I want you to put a point just in a different place. Put a point somewhere in a different place than what you did on that one. And do the same thing. Draw an angle to both ends of that diameter. And how big is that angle? 9 degrees. Okay, I just want to reinforce this. Okay. So the thing is if you have the diameter like this, okay, there's the diameter. This thing is lagging. Okay, so where you have the diameter, the angle drawn to that is always going to be 90. Okay, it's always going to be 90. Okay, the last thing I want to look at is this. So this is where you have a quadrilateral inscribed. And what inscribed means, as I've talked about already, it's where the vertices are on the outside edge of the circle, or where the corner of the shape is on the outside edge. See, the corner's there, corner's there, corner's there, and then the corner is there on this one. Okay, now this goes back to last unit, but in a quadrilateral, what do the four angles add up to? They always add up to 360, okay? So kind of keep that in your mind, but what I want you to do right now is to measure all four of these angles real quick. Measure those four angles, see how big they are. So they should be somewhere around there. Maybe off by a degree or two, but this is what it should be. This should be 77, 70, 103, and 110. Now, if you add all four of those up, they will add up to 360. But there's something else that's going on here. Does anybody see something else that's going on? Yep, we're inscribing a circle, but there's something else going on with the angles. Okay, good. So, like the angles that are diagonal to each other, the opposite angles, see how these two right here, if you add 110 to 70, what does that give you?
180.
That gives you 180. Okay, if you add 77 to 103, what do you get? You get 180 degrees also. Okay? So, when a quadrilateral is inscribed in a circle, the opposite angles are supplementary. They add up to 180. Okay? Opposite angles of an inscribed quadrilateral are supplementary. Okay, on the back. Okay, same thing. I'm not doing anything with that right there. Okay, so this one says find the measurement of angle F. So angle F is 4x plus 2. And the problem with knowing what angle F is I don't know the value of x. So I've got to figure out some relationship that I know here. Okay, so first of all, how big is angle G going to be?
90.
It's going to be 90 because it opens up to this 180-degree arc right here. Okay, now from there is a relationship that I know because what do I know about angle F, angle H, and angle G together?
Equal 180.
They add up to 180 because the three angles of a triangle always add up to 180. Okay, so we're going to have 4x plus 2, that's angle F, plus 9x minus 3, that's angle H, plus 90, that's angle G, all together equals 180. And just solving for x, so combining like terms, 4x and 9x is 13x, then 2, negative 3, and 90 makes what? Makes 89 equals 180. Subtract 89. 13x equals 91 divided by 13. And so x equals 7. And it's asking for the measurement of angle F. Okay, so I'm going to take this 7, I'm going to plug it in right there. 4 times 7 plus 2 is what? Is 30 degrees. Okay. And the last thing here is the last thing we talked about is quadrilateral inscribed opposite angles are supplementary. So down here on this last one, it wants us to find angle X and angle Z. So angle X is opposite to this angle. So what do we say about those opposite angles? They're supplementary. Good. So how big is angle X? Is 120. And then we're looking for angle Y. These two are opposite. So it's what? Is what? Yes, 85. To add up to 180. Okay, that is an inscribed quadrilateral.